Good morning, students. Myself, Vijay Shankar from EC Department, Civil Engineering College. So today I am going to discuss about the 4-bit adder and subtractor. 4-bit adder and subtractor. Second, I am sharing this one. The A is equal, A minus B is equal to, for 4-bit parallel subtractor, A minus B is equal to A plus the B bar plus 1. So these are equal of A minus B. We are converting the B as complement and you can add 1 to the LSB bit. Complement and you can add the LSB bit. So let us see the A minus B. Now I am taking the A as 1 0 0 1. Okay. And B is equal to 0 1 1 1. Let us take the example. Following my students. I am taking the A is equal to 1 0 0 1 and B is equal to 0 1 1 1. Means A is the similar of the A3, A2 and the A1, A0 only. B is equal to the same I am taking, that is a B3, whatever we take in the parallel adder, B2, B1 and the B0, my dear students. So to perform the A minus B subtraction, A minus B, so you can convert this into complement value. Complement. What is a complement here? I'm taking the A directly as of 1 0 0 1 and B is equal to nothing but it is a B bar. B bar is equal to converting this into the complement. One's complement. One's complement means zeros to ones and ones to zeros. So 0 is converted to the 1 and the 1 is 0 and 1 is 0 and the 1 is 0. Following. And you can add 1 to the LSB bit to get it is a 2's complement. Now you can see 1 plus 1. 1 plus 1 is a 1 0. 1 plus 1 is a 1 0. The carry is 1 here. And 0 plus 1 means it is a 1. The carry is a 0 here. Okay, here the carry is a 0. Following my students, and 0 plus 0, that is a 0 only. And here also the carry is a 0 only. Carry is a 0. Following. And 1 plus 1 is 1 0. 1 is a carry and 0 is a sum. See, in this subtraction, if any carries occurs, we are ignoring that one. In the 2's complement form, subtraction operation, 1's complement means we are adding to the LSB bit of the carry. But here we got the carry, whatever the carry is there, that carry is ignored. See, what is the A we taken? That is a 9. A is a 9. See, let us see here. A is 9 we taken. And B is a 7. Okay, A is a 9. What is a 9 minus 7? 9 minus 7 is a 2. So 2 is a decimal value. Now you can see the binary of 2 is 0 0 1 0 only. 0 0 1 0. Following. So in this, you can observe here, whatever I kept here, the 1 LSB bit, I added 1 to the LSB bit. That is the C in the 4-bit parallel subtractor. 4-bit parallel subtractor. And whatever the 0 we got, that 0 is a S0. And here there is a carry is there, that carry is a C0. And sum is S1. And the carry here, it is a C1. And sum is S2. And whatever the carry is here, that is a C2 and sum is S3. and final carry is there. That carry is a C3 or C out. Okay, because of we are performing the subtraction operation, we are ignoring this carry. Okay, ignore the carry. Following my students, means the sum whatever it is there, S0, S1, S2 and S3, that is the value of the two, nothing but the binary of the 2, 0, 0, 1, 0. Following my students. Now if you can, I'm adding that in the screen, you can see the first full adder, that is F0. So first bit if I am taking that as A0, and Cin you can see that is a 1, you can add it to LSB bit, that Cin is equal to 1. Cin is equal to 1. Let us see here, Cin is equal to 1. What is a A0 is a 1 and B0 is a 0. Then, but B0, how we got the B0 is a 0? We are complemented of a given number, given binary number 0, 111. Okay, in the 0, 111. Now I am taking this as B0 as a B bar. So I am taking the complement here. Complement of this one. So B0. You'll get the B0 bar here. Following. And it will get S0 by taking off A0 and the B0 bar with Cin as 1. S0 is output and C0. So let us see here. We got the S0 and the C0 is 1. Similarly, another full adder I am taking, another full adder, that name it as full adder 1, by taking off next bit of A, that is A1, and next bit of B with the complement value. So I am using the inverter here, B1. Okay, and it gets the S1 and also the C1 carry. Okay, now you can see here, you see the S1 is 1 we got, and the C1 is a 0. C1 is a 0 by taking off A1 and the B1 with the C0 is a 1, and it gets the S1 and the C1. Following. Then another full adder I am taking here, another full adder, that is a name it as a full adder 2, by A2 as 1 bit and B2, that is a B2 bar. So I convert into the ones complement, B2 bar, and performs the operation of the full adder, and it generates the S2 and the C2. S2 and C2. Let us see here. S2 we got by taking off A1 and by taking off A2 and B2 with C1. C1 as a carry from A1 and B1. So you'll get the C2 and S2. C2 and S2. C2 and S2. Then after, if I am drawing here, see, another full adder I am taking, that is F3, and with the last bit MSB bit of A3 and last MSB bit of B3 bar. So I am using here the inverters. Okay, my dear students, I can understand this one. Then the last full adder, it generates S3 as output and C3, that is nothing but the C out. Okay, so that is only we got the S0, S1, S2 and S3. The C3 we got as a 1 by taking off A is 9 and the B is 7 that 7 is converted to the B bar as 1000 and 1 is added here, that is 1 is added here as a carry, means for subtraction operation Cin is always 1, Cin is always 1, and for addition operation Cin is always 0, Cin is always 0. Following my dear students? So B only we are converting into the ones complement and adding 1 to the LSB bit. Adding to the 1 to the LSB bit means the Cin is a 1 only. Okay. You can take any example. So in this, as per our material in the 21st page, I took that it is a 1001 as A values and B is a 5, 01, 01, 01 and the 01. Following my students. 01 and the 01. So now you can see the A is equal to, which is taken as a 9 and the B is equal to 5. Is a 9 as a decimal value and the 5 is there. Okay, 5. But for subtraction operation of this one, so 1001 you can take and convert this as a complement value 1010 and add 1 to the LSB bit. So 1 and 1 is a 10 is a carry this one, and 1 plus 1 the carry is 1 and the 0, and 1 here directly and 1 and the 0 here. Now let us see, and the last one is ignoring this one. So 0 1 0 0, 0 1 0 0 is a nothing but 4. Following 9 minus 5 is a 4. 9 minus 5 is a 4. So 1 plus 1 is a 0. 1 plus 1 is a 1 0. And 1 is directly I'm taking 1 plus 1 is a 1 0. The carry is ignored here. Following. So whatever you are getting the same thing. So B is complemented and add 1 to the LSB bit. This is a Cin. Cin is 1. Okay. I took here this 9 and the 5 and something with the examples. Following my dear students, I hope you've understood everything. A minus B, always it is A plus B bar plus 1 only. A minus B means A plus B bar plus 1. Okay, take it is the first full adder is taking off A naught, B naught bar plus 1. Okay, and second full adder you can see here, second full adder is taking A1, B1 bar and C naught. That is a B1 bar here. We'll get the B1 bar. After inverter, it is a B1 bar. After inverter, it is a B naught bar. And after inverter, here it is a B2 bar. And after inverter, it is a B3 bar. So first full adder is taking off A naught, B naught bar and the Cin is a 1. And it gets a S naught and C naught. And second full adder is taking off A1, B1 bar and C naught, it gets the S1 and C1. And third full adder is taking off A2, B2 bar and C1 bar and it gets the S2, S3, S2, C2. And the last full adder is taking off A3, B3 bar and also C2. It gets the S3 and the C3 or it is a C out. Okay, my dear students. So in this, whatever the carry we got as a C naught or a C out, we are ignoring the one. Ignore. The carry is ignored in the subtraction operation, nothing but 2's complement operation. Subtraction, I'm not saying that it is a subtraction. Subtraction using the 2's complement. Subtraction using 1's complement is there. But we are not ignoring the C out or the carry. We are adding that carry to the LSB bit again. And answer is not in terms of the true value, it is a complement value. Again, you can say convert into the complement when it is in the 1's complement subtraction. But here it is a 2's complement subtraction only. Understood, my dear students? So in the tomorrow's class, again, I will explain by sharing the screen. I hope everybody can attend the from further classes. Only the three are the always the 3 members only. Regularly presenting. Today also only the 3. Following. The tomorrow class, you'll see the next topic. It is a binary adder and subtractor. Binary adder and subtractor. The combining of adder and combining the subtractor within the same device. Okay, by using the mode operation. When you use the mode operation, m is equal to 0, it performs the addition operation. When m is equal to 1, it performs the subtraction operation. Means simply m is nothing but Cin only. When Cin is a 0, it is addition operation. And Cin is equal to 1, it is a subtraction operation. But how we can change that as a B0 and the B0 bar? Subtraction operation means it gets the second bit as a complement value. Addition operation means the first and the second is both are uncomplement values only. What are the given values? All right. Within the same